All right, so when we graph these three functions and then compare them to the parent function, this is what we get. All right, so just to kind of recap, this is a concept. We'll talk about it in a second, but let's hide some of these. When I go to cosine, notice that the maximum value is 1, right? And we knew that because we said the range was from -1 to 1. So the maximum value is 1. No matter where you go, at the top of every one of these hills is going to be 1. Okay? So now if I put a 2 in front of it, it's basically the same graph, but now my maximum value is 2. Every one of the tops of those hills and the valleys are -2. Okay? Now, if I go and I change that first number to a 4, the graph pretty much looks the same, but now my maximum value is 4. And my minimum value is -4. And you guys already know the answer to this, but what happens when I click here for the 1/2? What's the maximum value and the minimum value going to be? 0.5 or 1/2. So if I go to the purple line, it's going to be 0.5 or -0.5, which is 1/2. So then, what does that mean? Well, whoops. That means that we can think in terms of this. Y equals A. And then you could put cosine of x, where A is what we call the amplitude. It's a scalar multiplier, which is a fancy math way of saying whatever the y value is, we're going to multiply it by whatever A is. Okay? So what would happen if I were to say y equals 6 times cosine, oops, that's not a very good C, cosine of x? Yeah, the minimum and maximum value, let's see. If I come in here and I say y equals 6 cosine of x, guess what? The maximum value will be 6. And consequently, the minimum value will be -6. We're taking that original range of 1 to -1, and we're just multiplying it by 6. And that makes sense, right? Cosine really represents a number, and then I'm multiplying that number by 6. Okay? All right. So that's basically it for example number 1. And what does that mean? So I'm going to write this down for you guys a little bit more formal. Actually, I'm going to let you guys write it down. And I'll talk about it slowly as you guys write it down. So for sinusogenous functions, and that's a fancy math way to say trig functions, or sine and cosine. Well, I should probably write it in the other order, right? Because that's what it is on the xy plane. For cosine and sine. That's what sinusogenous means. The form y equals capital A sine of x and capital A cosine of x, where A is the amplitude. Now, here are some things you should know. When A is less than 1, the graph is compressed vertically. When A is greater than 1, it's stretched vertically. Okay? So if I have, what we did was, I had cosine, and then when I put a number in front of it, like 2, it stretched it. When I put 4, it stretched it more. When I put 6, it stretched it even bigger. So let's look at that real quick. I'm sorry, I know you guys are watching this stuff, but or trying to write that down. So here it is at 2. See how it stretched it? Here it is at 4. Here it is at 6. Now another way that you could do this, and then I'll go back to the screen so you can write it down. I could say a times this and put a slider in there. So watch what happens when I change the value of x in real time. As I increase the value of x, it stretches it. So that's for values greater than 1. Now anything less than 1 to 0, watch, as soon as a gets less than 1, it compresses it. See how that works? And that's what all this stuff means. It means that when a is less than 1, and when the absolute value of a is less than 1, because you can have a negative 0.5, which means the absolute value is less than 1. So don't forget the absolute value part. I kind of glossed over that. Okay? What happens when it becomes negative, if you guys were to guess? Yeah, it just flips over. But so in other words, if a was negative 1/4, it would still compress it because the absolute value of negative 1/4 is 1/4. So the amplitude would still be 1/4. And so you would take the regular, whether it be sine or cosine, and you compress it.